Hello, this is John from kforprogramming.com. In this tutorial we're going to take a look at template functions and type inference. So I gave you an exercise last time, which is to try to find some code where actually putting in a type here will actually make a difference, because as we've seen you can miss it out and C++ will infer what type you mean. Well, supposing we have two functions with identical names, and remember we can do that because we can overload functions as long as the argument list is different. So the argument list has got to be different. It's not enough for the return type to be different. We could have another function here called print, and print could take, let's say, an int value, and we could output the value here. So let's put in some extra text here. So non-template version, and here we're going to have template version. So template version. So how do we select which function we want here? So if I run this now, let's just see what I did wrong there. So I've got my cout, I've got my print. What's it say? I've got there's this bug in CDT, at least for my version here, which complains about endler, but the problem here is that I've just got n instead of value. Okay, so this works. All right, so here we're calling the template version, and that's because I'm not calling, I never call int here, I never call print with an int, where I'm not specifying that I want to use the template version of the function. So if I call print and I just pass in 6, let's say, if I run this, the closer match for this is actually this function here, because this kind of takes an int as its parameter. It's an actual int. So C++ considers this, in this case, to be a better candidate than this, at least with this compiler. So let's run this, and we see we get non-template function here. If I actually wanted to run the template version of this overloaded function, I'd have to put in at least diamond brackets here. So I could actually miss out the type, but just by putting those in, it clues in C++ that I want the template version of this function, and it will do type inference because the type is present in the argument list, so it can work out here which type I actually mean for this, for T. So if I run this, this gives us the template version, whereas simply this will give us the non-template version. So again, you can, if there's no ambiguity, you haven't got different versions of the same function, you can often miss out the type, and you can often miss out even the diamond brackets altogether. But there are situations in which your code's literally not going to compile, so you can't run your template function unless you put not only the diamond brackets like this in, but you also put the type in as well. So if you like another exercise, then it's worth trying to figure out what that situation is. Can you code a situation in which your code literally won't compile unless you put in not only these diamond brackets, but also put in the type as well? So I'll show you the answer to that now. So if you want to think about that and have a go, then do pause the video at this point. Okay, so let's take a look at the answer. So remember that the C++ looks at the argument list to infer the type you mean if you try to use type inference with this, or by not specifying the even the diamond brackets at all. So let's say we have a template function. Let's copy this and have another one. Let's call this, I'll call it show instead of print. And this time we won't use the template in the argument list. So what I'll do is I'll just call T. So we'll create a new T, run its constructor, and output it directly. Now in this case, I can't call show like this, because so this actually gives me an error. If I try to build this, I'm going to get an error here. Let's build it and prove that. So here's an error. The reason for that is there's no argument list, so I'm using the type T. I could use it as a return value if I want. Here I'm just using it, I'm just outputting it directly, constructing an object from it and outputting that object. I could also use it as a local variable, but if it's not in the argument list, C++ can't infer the type. Therefore you can't do this, and you can't even do this, because again, if it's not in the argument list, then you can't infer the type. If it's not on the list, you're not getting in. So here we need the type. So let's put, for example, double, and this will actually work. This will give us a double which is initialized to the default value for double. So if I build this project now, the error goes away, and we can run it, and we get naught or 0.0 or whatever, but it's just displaying it as naught. Okay, so that's it for this tutorial. It's well worth having a go at this and verifying those for yourself, the different situations where you do or do not need to specify the type when you run the function. And remember that you can use this in the argument list. You can have multiple ones separated by commas if you want. That's no problem as well. You can use type name here instead of class. It's just equivalent. And you can use this either as the return type or as a local variable, as well as in the argument list. So all of these things are possible. Okay, so until next time, happy coding.